third section of the algebra unit. This is radical rules, and just like exponential rules, radical rules are very much the same, because remember, we can write things as exponents and that's equivalent to radicals, and so on and so forth. So our rules are going to look pretty similar. So if you title your page Radical Rules, okay, they're radical rules. Okay, so just like we talked about exponents, remember this, that I can write the square root of x is x to the 1/2. Whatever number is at the top of the fraction in my exponent, that is the power that my x is raised to. The number on the bottom represents the root of my radical. And so again, if I wanted to do something like the cubed root of x, that would be x to the 1/3 power. And so that was in our radical rules. Now, if I have something where, let's say I have the nth power of a times b, I can separate this out into two radicals with that same, has to have the same root value. Okay, now if I'm going to multiply two things together, if I want to multiply these two things together, these have to have the same root value, and then I could multiply these two numbers together to get back into one radical. If this is 3 and this is 4, I could write this as n radical 12, because I could multiply them together. If these roots are different, then I cannot multiply them together. They'll just sit next to each other because they can't be combined. And then remember that multiplication and division are inverses of each other. So if you had something like this, you could also write it like this. And if you're given this, if these are the same root number, you can divide these two numbers together and then take the root, that root of the whole thing. Some cautionary warning for you. We can only add and subtract radicals with the same radicand. Now notice up here, multiplying and dividing, they can be different. This is A, this is B. We can multiply and divide them if they're different. But for adding and subtracting, if I had something like, let's see, the square root of A plus the square root of A, because those match, think of it as collecting like terms, okay, for adding and subtracting. Now I have two of these guys. So I have two radical A's, right? And I can collect them, but I cannot write that as the radical of 2a, okay? Or you're obviously not multiplying b a squared or anything like that, but you can collect like terms, but they have to be like terms, okay? And if I had like 3 radical a's plus 4 radical a's, then I have 7 radical a's, and that's fine. You can collect them, but if the insides are different at all, you cannot combine them. Okay, that's the cautionary tale. So let's see an example. So example 1, you could have something like this: 2 radical 7 plus 5 radical 3 minus 4 radical 3. The radical 7 gets to stand on its own because it doesn't have any friends. So 2 radical 7 is just going to be that. But here I have these match. So 5 radical 3 minus 4 radical 3, well, that means I have 1 radical 3. And now that is the answer. You can't do anything more. Please do not write 2 radical 10. I will smack you. No, I won't. I really won't. But don't do it. Don't combine them. They're not the same. Okay, that's one of the mistakes kids make. You're trying to simplify as much as you can, so you just keep going and going and going until you get in trouble. Okay, so let's try one that looks like this. What if I run on this? Let me flip. Okay. So we'll get down into the crazies. Oh, I was also going to talk about, before I do this, well, I'm going to put the problem up here, and then we'll figure that out in a second. 5 radical 162 plus 3 times radical 28 minus 8 radical 18. Okay, so we have this. None of these guys are the same. So I have to figure out if I can get them to be the same. So when I'm thinking exponents, I want you to think the same thing here. We're going to talk about some squares and some cubes. So some perfect squares. Remember 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Okay, here's my perfect squares. 8 times 8. Okay, perfect squares. Since this is a problem dealing with square roots, having some perfect squares would be nice to know. So I can take my handy dandy calculator. This is just how I do it. And I just say 162. Let me just try 16. Nope. 162, try, and obviously not 25. 36? Nope. 162 divided by 64? Nope. Nope. Ah, 81 worked. Okay. So I just started dividing it. I guess can't see that very well. 162 divided by 81 is 2. So I found a perfect square. You can also do a factor tree if you want. Just start dividing that by 2 and then figure out, what kind of factors you got. But I think it's easier to just do that. So I just divided. I know my perfect squares. I think that's easy. So remember that this is 81 times 2. So I'm making a little factor tree anyway. But what I want you to think of is 81 is 9 squared, right? 81 is 9 squared. Well, what's the square root of 9 squared? I hope you all said 9, right? The square root of 9 squared is 9. So on the outside, I have 5 times 9. The 2 is left on the inside of that radical. And furthermore, that's 45. And I multiply those, whatever on the outside. 28, I know that's divisible by 4. That's 4 and 7. And the square root of 4 is 2. So 3 times 2 is 6. If I went too fast, I'm sorry. That one's an easy one. Square root of 4 is 2. 2 times 3 is 6. So 7's left over on the inside. 18 has a 9. That's 9 and 2. I don't know why I'm writing them in different orders. The square root of 9 is 3. So that's 24 with a radical 2. Square root of 9 is 3. 3 times 8 is 24. Okay, and this was a plus. And that was a minus. Okay, so 45 radical 2 and this 24 radical 2, because they both have radical 2's, I can now combine like terms of the 45 and the negative 24. So I can add 45 minus 24. So that's 21 radical 2's. And that's just going to be 6 radical 7. Can I combine these two things together? Nope. Nope, nope. Let me see if we can do one where there's some cubed root action going on. So let's try one with cubed roots. Okay, so remember you can pause if you need to copy that. I'm going to have to move the screen. But let's do one with cubed roots just so we know kind of how that works. So if I had like negative 2 cubed root of 448 minus 3 cubed root of 189. Big numbers. Okay, cubes are big. So let's think of our cubes. I'm just going to write those off to the side. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 3 times 3 times 3. 4 cubed is 64. 5 cubed is 125. 6 cubed, I'm going to put in my calculator because it's 216. Okay. That's probably good. I'm going to stop there. 448, I'm going to try and divide it by 64. Nailed it. 448 divided by 64 is 7. Let me see that. 7. So I know that this is 64 and 7. The cubed root of 64 is 4. So negative 8 cubed root of 7, right? 189 is divided by 8. No, it wouldn't be divisible by 8. 189 divided by 27. Yeah. 189 divided by 27 is 7. Cube root of 27 is 3. 3 times 3 is 9. And I have a 7 left over. Negative 8 and negative 9. When I put those together, that's 17. Oh, that's a cube root of 7. My bad. Negative 8 minus 9. 17. Ta-da! And I get 1 radical. All right. You can now work on, you have a worksheet that's called Operations with Radicals. Now, if you're watching this on Wednesday like you're supposed to, you might, if you're Group B, you haven't gotten this until Thursday. So you're just watching these videos and you will get the in-paper worksheet that looks like this. And so as you do these, you will work out column 1 and you can put your solutions here. You will then work out column 2, which some of them are a little bit easier and some of them not. And as you're going, you're going to get and put your solutions here. Whatever the answer is to number 1, it'll match a solution over here in column 2, and that's your color that you color your 1s with. So on your coloring sheet, you color your 1s if it's red or orange, green, whatever. And you can sub out colors if you don't have all these colors. So if you have something crazy at home, whatever, just sub it out and you can use that to color your picture with. So that will work. All right, well, I will post this document if you want to get a head start on it, but I will be giving this to you in class physically when I see you on Thursday. So happy learning.